Hello everyone. Today I am going to discuss about the various imperfections in the solids. Imperfections in a solids. Normally these imperfections in solids we are going to get when we are going to give the heat treatment process in the solids. During the solidification process, this imperfections is going to occur in the materials. Normally when there is a imperfections in the solids, the material strength it is going to be decreased. So we have to avoid this kind of imperfections, but you should know before how it is going to develop in the material. We will see what are the various different kind of imperfections we have. First we will see the different types of imperfections in the solids. The first one is point defect, or we can call it as imperfections. The defect and imperfections both are same. This is the first one, and this we can call it as one dimensional or zero dimensional defect. Zero dimensional defect we can call it as. And second one is line imperfections. This we can call it as one dimensional defect. The third one is the surface imperfections. This we can call it as two dimensional defect. And the last one is the volume defect or volume imperfection we can call it as. So these are the three dimensional defects. So these are the various imperfections or defects we can call it as. The first one is the point defect, the second one is the line defect, and third one is surface defect, fourth one is the volume defect. So these are the various defects we are going to get in the solids during the heat treatment process or the solidification process. First we will see one by one. But before going to explain all this, I want to explain what is exactly defect, the definition of defect. The defect we can define when there is a misarrangement or when there is a deviation in the standard arrangement. When there is a deviation in the standard arrangement, so that we can call it as a defect. So normally if you see any material, so there is a atoms like this, okay. So suppose if these atoms are arranged in a proper or a standard arrangement, so then we can call it as a perfect crystal. Suppose if there is any deviation in the arrangement of these atoms, so that we can call it as the defect, okay. So there is a defect, the material strength it is going to be decreased, okay. So we will see what is a point defect. In the point defect again we have the different types. In the point defect, so we have vacancy defect and we have interstitial defect, and also we have impurity defect, and we have Frankl defect, and also we have Schottky defect. So these are the various types of point defects. So the name itself says the point defect, that means so we are talking about the particular point. So when the arrangement of the atoms in the lattice space, it is deviating from this original position or particular point, that kind of defect we can call it as the point defect. That means the atoms are missing at that particular point, that we can call it as the point defect. That means the atoms it is deviating from its original point. So that kind of defects we can call it as the point defects, okay. So in this, the first one is the vacancy defect. So we will see what is vacancy defect. So in the vacancy defect, so there will be a one vacancy. That means when if you see the arrangement of the atoms, okay, so the atom is missing in its position, atom is missing in its position. So due to that there is a vacancy. Okay, see here. So I am indicating with dotted line. So here in this particular position one atom should be there, but so here it is missing. So due to the missing of this atom, okay, so this vacancy is created in the lattice space. Okay, so due to this we will get this kind of vacancy defect. Okay, so this we can call it as the vacancy defect. So when there is a vacancy defect, one atom is missing, right? So due to the missing of one atom in the lattice space, the total strength or total density of the material, it is going to be decreased. Okay, so when there is a decrease in the density of the material, the strength also it will be decreased. Okay, so here I am indicating D means density and S means strength. So when there is a decrease in the density, so the strength of the material also it is decreased. So normally this kind of defects we are going to observe when we are going to heat the material or when there is a solidification process. So during that, so atoms it is missing at that particular point and it will be missed somewhere else. So that we will see in the vacancy defect. So the next one is the interstitial defect. So if you take this one only, see here there is a vacancy, right, because of missing of one atom. In the same similar way, so in the interstitial defect, the atom is occupying the interstitial space between the atoms. Okay, so suppose there is a anions and cations in the lattice space. Okay, so in the interstitial defect, the atom it is going to miss its position and it is going to occupy the interstitial space between the two atoms. Okay, the atom is occupying the interstitial space. Instead of its original position, it is going to occupy the interstitial space between these atoms. So this kind of defect we can call it as interstitial defect. Interstitial defect. Okay, so because of this, the density of the material it is going to be increased. Density is going to be increased. So due to the increasing of density, the strength of the material it is going to be increased. Okay, so this is the interstitial defect. The third one is the impurity defect. Impurity means, so when you see the any lattice of the any material, so there will be a cations and there will be a anions. Okay, but sometimes what is going to happen, the other atom it is going to come and it is going to occupy the space of the cation or anion. So here I am indicating the small one anions and the bigger one, suppose it is a cations. So here I am indicating plus minus, so that will indicate the positive ions and negative ions. Okay, so that only we can call it as the anion and cations. Okay, so sometimes what will happen, due to the solidification process, okay, so this atoms it is going to be occupy the foreign material. The foreign atom it is going to come and it is going to occupy. So here, so this is the foreign atom and it is occupying the anion space. So see here, so this is and this is two are different atoms. If you see this line, so these are all similar, that cations are all are similar, anions are same similar, but here this particular atom it is looking different, right, because it is a foreign atom, it is coming into the lattice and it is occupying the space. So when there is a foreign atom it is coming and occupying the space in the lattice, so that we can call it as the impurity defect. Impurity defect. Okay, so suppose if you take NaCl, okay, NaCl, the Na plus Cl minus should be there in this, but sometimes what will happen, so instead of Na, so the sulfate it is going to come in, it is going to occupy this space in this. So that kind of defect we can call it as the impurity defect. Okay, so next one is the Frankl defect. In the Frankl defect, the two things is going to happen. So first we have discussed about the vacancy, right? In the vacancy there will be a empty space will be there, right? And in the interstitial, the atom, it is going to occupy the interstitial space. The two things, the combination of vacancy and the interstitial pair, we can call it as the Frankl defect. Okay, so here I will show what is the Frankl defect. Suppose this is the lattice space. Okay, so here these are the atoms. So here one atom is missing. Okay, so because of vacancy, so here it is creating the vacancy defect. Okay, this is the vacancy defect because here this atom is missing, right? And next, I told you there is a combination of vacancy and interstitial. Right? In the interstitial, what will happen? In the extra atom, it is going to come and it is going to occupy this space. Okay, so here one extra atom it is coming and it is occupying the interstitial space between these two atoms. Okay, so due to that, so here it is creating the interstitial space. Okay, so here the combination of this vacancy and interstitial, we can call it as the Frankl defect. Otherwise, we can say it as the vacancy and interstitial combination. So we can call it as the Frankl defect. Okay, so there will be one empty atom, and also here the same empty atom, so it is going to come and it is going to occupy the space between these two atoms, that is the interstitial space. Okay, so due to that, so there is any variation. See here one atom is missing and here one atom is occupying. I told you in the vacancy defect, so due to the missing of one atom, the density is decreasing, so that the strength of the material also decreasing. But in the interstitial defect, so here one extra atom it is coming and occupying the interstitial space. Because of that, the density is increasing, so that the strength of the material also it is increasing. So in this case, what will happen? The density is going to increase or decrease? And what about the strength? Whether it is going to be increased or decreased? See here, one atom is missing, the same atom it is going to come and it is occupying the interstitial space, because the total density of the lattice it is not going to be vary, right? The total atoms are equal, so there is no variation in the density. Okay, the density it is not going to vary, so that the strength of the material is also it is not going to vary. Okay, so that it will maintain some neutrality. Okay, so there is no variation in the density, so that it will maintain the electron neutrality in the lattice, so that there is no variation in the strength. Okay, that you should remember. Okay, this is about the Frankl defect. The last one is the Schottky defect. The Schottky defect, it is also the combination of one cation and one anion. Cation, anion, suppose it is missing in the lattice space, that we can call it as the Schottky defect. Here I will show. So normally one cation, one anion, one cation, one anion, it will be there. Okay, in the lattice space. Okay. Suppose if there is any one positive ion, one negative ion is missing. So here I am removing this cation and one anion. Okay. So because of missing of these two, one cation, one anion, so here the Schottky defect it is going to be created in the solid materials. Okay, so here one positive ion should be there, one negative ion should be there. Okay, but here I am removing one positive and negative ion, that is cation and anion it is missing. The pair of cation and anion missing in the lattice space, we can call it the Schottky defect. Here one thing you should remember, so it is not mandatory to remove only one pair of cation and anion. So maybe sometimes we can remove two pairs, sometimes three pairs. So if you remove any number of one pair of cation and anion, that we can consider as a Schottky defect. Okay, so maybe sometimes 2 pairs, maybe sometimes 3 pairs. Okay, it depends upon the what kind of material we are using during the solidification process or the heat treatment process. Okay, to maintain the neutrality, so we are removing one pair of positive and one pair of negative ion, so that the pair of cation anion, suppose if you are removing from the lattice space, that we can call it as the Schottky defect. Okay, so these are all the point defects. We are talking about the particular point here. So here I mentioned the point. Okay, if there is any variation in the particular point of the atom in the lattice space, so that we will consider as a point imperfections. Okay, so here we can call it as the zero dimensional defect. These are all comes under zero dimensional defects, because only we are talking about the particular point, it is not going anywhere else, right? So because of that we can call it as the dimensional defect. The second one is the line defect. The line defect, we are saying it as a one dimensional defect. One dimensional means, so there is a one direction, it may be horizontal or it may be vertical. So in that particular position the movements of the atoms will be there. Okay, so if you take line defect, the name itself says in the line there is a missing of atoms will be there. Okay, so here if take this line, so here some atoms are arranged in the lattice space. Okay, but sometimes what will happen, in this particular line there is a deviation, there is a imperfection in the arrangement of the atoms. So that kind of imperfections or the defects we can call it as the line defects. Okay, I will show how it will be. Sometimes suppose if you take this particular line, okay, the atom should be there exactly in the vertical position or in the horizontal position. But sometimes what will happen, see here in the next row I am showing, so atom it is missing from, it should be here but it is missing here, and here also one atom should be there, instead of in this particular line, so it is occupying somewhere else, so it is not exactly in this line, right? So this kind of deviation in that particular direction or line, so we are considering it as a line defect. Okay, so in the line defect again we have different types. Okay, so here I will show. So normally the arrangement of atoms should be perfect, but sometimes it will be like this. So here it is not in the exact line, right? So this kind of defects we can call it as the line defect. In the line defect we have two types. Okay, one is the screw defect, the second one is edge defect. So these are the two different types of defects we have in the line defect. Naresh?